you want to do something like find the equation of the circle with centre 6, 4 and radius 3. Right, so if we draw some axes, if we had a circle that was centred at the origin, in other words like that, we'd know that the formula would begin x squared plus y squared equals, and then the other side would have the radius squared. In this case, I know I'm ignoring that for a moment, but in this case we have radius 3, and so we know that our radius out there is 3, and so over here this is the radius squared, so we'd have x squared plus y squared equals 9. That would be if it was centered at the origin. Now if it's not centered at the origin and we've got the coordinate where we need the centering to be, well, all we need to do actually, and I will explain this, but all we need to do actually is reverse these signs and write this. So we'd say x minus 6, so I've taken the positive 6 here, I reversed its sign for the x coordinate and put that in a bracket and squared it, plus y minus 4 all squared. So I've taken the positive 4 here, I made it a negative 4 within the bracket and squared the bracket, and that would equal 9. Now that would take our circle out to a centre of 6, 4, but with the same radius of 3. Now let's examine that a little bit and see why that might be the case. What we've got is a circle that's kind of up here, and so we want the centre to be at the coordinate 6 and 4. And we know that the radius here, well, that's going to be 3 because it's going to be the square root of this. And then if we put a couple of lines in to make a triangle, a right angled triangle here. Now, if you consider that we know that this distance to here is 6, if we go a little bit further up, we can call that distance at the end of the bottom of the triangle, we could call it x. And therefore, this distance is x minus the 6. So it's the x distance minus the 6. And if we look here, well, we know that this is at 4. And here we've got something that we could call y. So the distance y is all the way up. If we take away the 4, then we have the distance here. So that's y minus 4. Now, in order to get the length of the hypotenuse, we would do Pythagoras. So what we'd say is x minus 6 squared plus y minus 4 squared. And remember, it's the square root of those added up to get the hypotenuse. So equals 3, the length of the hypotenuse. So we've used Pythagoras. X minus 6 squared plus y minus 4 squared, all square rooted, should give us the length of the hypotenuse. And that's how we'd write it. Now, if I wanted to get rid of this big square root sign on the left hand side, I could square through. And if I square through, I get x minus 6 squared plus y minus 4 all squared equals the square root of 3 is 9. Exactly as we had here. So that's just a little proof of why this would be the case. But the shortcut, of course, is to see the coordinate, reverse the signs to minus, and remember to put it in the brackets, and then to square the radius. And that would give you, and also this, would give you the equation of this particular circle, centered at 6, 4, with a radius of 3. So there we go.